Okay.
This weird problem on this ice table that we just crossed out.
It was bad. Like, this is the first time I've ever had time to work through this together with people, and the problem was broken. So,
Automatically wrong the second they decided to use CH3 NH2 as this.
I know. It was... These are pretty good for the most part, but whoever made this has some mistakes.
Can we change?
Whoever this person is. I bought these. No. I purchased these. So, yeah, I did not make this. I would not publish something that has this many mistakes. Like, that is a lot. Here we go. 15 minutes. Then we're going to go to a gym kit. Then we'll finish the second 15 minutes. I think I can finish this in 30 minutes between the two classes. So, a strong base will have a weak or strong conjugate acid. Why? You're right, but why?
Because it's bad at donating.
A strong base will accept and hold the proton tight, right? Yes? So that means that the resulting conjugate acid is going to be very unlikely to let it go. And what does that mean? That means it's a weak, because it will not let it go. Weak bases have a pH range of, what would you guys say?
Weak bases.
Like 7 to 10, something like that. And have small or large equilibrium constants. Small. Many weak bases contain the element what? Nitrogen. Because it has a lone pair of electrons that is able to bond with H+. So, below is a reaction showing the dissociation of a carboxylic acid, including resonance structures. So there's resonance here. This double bond can go between the O on the hydroxide or this O out here by itself. So this double bond can flip. Label the acid base, conjugate base. So, right here. Is this my acid or my base? What would you guys say?
Give away the H, right? 2.
Okay.
Oh wait. The bottom one, does the bottom one have a negative charge?
This is my acid. Therefore, water is my base. You got it. So H3O plus is my conjugate acid. And this is going to be my conjugate base. Okay. Anyone want to take a shot at this? How would resonance in the carboxylic acid increase the acidity?
Is it like the it was just a larger difference in more electronegative.
Mm-hmm.
More electronegative. And
You got
the
it.
more electronegative it is, the more electronegative it is, the more it's going to want to attract.
The electrons, right? The electrons can pull away.
Oh, right, and that makes it easier to let go of the H.
Yes. From, can pull away from the OH group. It can pull away from the OH group towards oxygen, right? Towards oxygen, which is more electronegative, right? More E negative. Which would increase the polarity. That essentially increases the polarity of the OH bond. As Megan was saying, making it easier to pull off an H+. To pull an H+. Explain how the resonance structures of the RCOO- increases the acidity of the carboxylic acid. So the RCOO-, right? What can the electrons do for this? Electrons can what? There's 2 oxygen atoms. What can the electrons do between these? They can delocalize, right? Because in these resonance structures, this one has 2, this one has 3. In this resonance structure, this one has 3, this one has 2. If they're delocalized, right, electrons can delocalize, let's say, between the two oxygen atoms. What's it going to do to the stability? That makes it more stable. Because those electrons can spread out more. So it's more stable. Therefore, that means the RCOOH is going to have a more likelihood of donating the H. So therefore, your RCOO is more likely to donate an H. That's kind of going deep on this. I don't think you would see something like that on the AP test, but it's good to know. It's good to know. Consider the following acids in order of increasing strength. Did I hit record? I did. Circle the acid with the most stable conjugate base. What? The most stable conjugate base. So let's think about what that means.
They are in order, right? Like from left to right, they are in order from weakest to strongest.
Well, it says consider.
So these are in order. These are.
Oh.
So let's consider the following acids in order. So this is my weakest, this is my strongest. What does the most stable base mean?
It won't do it. Like stable means it will be less likely to react.
So it's going to be the weakest.
So HF.
Yes. You got it.
Oh.
So it's going to be HF. Why? Flip it.
Fluorine is gonna. Oh wait, fluorine can't attract.
Strongest acid has the weakest conjugate.
Fluorine is the most electronegative what? Element. Most electronegative element. So it's super stable. That's why.
That can attract a
Correct. So complete the chart. pH versus pKa. So on this chart, we have Ka equals 1 at equilibrium. What if I just made up a word, equilibrium? I'm so hungry right now. Like, I'm starving. I've been eating breakfast more often recently, and I didn't eat it today, and I regret it.
Have you ever eaten one of Mark Wahlberg's burgers? There's like a place.
I have been to Wahlburger. No, it's not.
Yeah, it's the onion rings. I was like, oh.
Where did they?
I've been to
I was
Wahlburger
hungry and I was like, oh, I could eat a burger.
when I was at a training in Harvard in Boston. That's when I went to Wahlburger. I thought it was good.
Like the burger was good, but
What?
is there one around here?
Is there one? I think there's one in downtown Cleveland.
Yeah.
Yeah.
Like, why have a good burger and then have like nasty onion rings? Like that just sounds really good.
Just don't get the onion crispy.
It was like,
So the burger was good, but you're complaining about the onion rings?
yeah.
I just heard that there's a Michelin chef that has a restaurant in Akron. Has anybody been to it? It's like right across from Luigi's. And you can buy like a $120 steak that feeds 2 people.
Why would I
I think
spend
any of us would
$100?
want to
What is it called?
I don't know.
I could buy 3 copies of Donuts.
I just need someone to go with me. It's 48 ounces of steak.
Holy crap.
So that's like 3 pounds of steak.
Chad, that would give me a heart attack. Like I would die.
Yeah.
I would never eat that.
I want to go to like a different I don't know if they have this, but like they have different steaks you try. So like you have filet, ribeye.
steak flight.
That would be so
A
good.
steak flight. I would pay for that.
I think they have one in Cleveland.
Did you know that a T-bone is like half filet and half sirloin or something? That's what a T-bone. Yeah, that's why it's a T-bone. Because the bone that goes in the middle splits 2 different types of steak. So
How do they tell them 2 types of
it's where it comes from, the cow.
I've never had steak.
Oh, okay. Wait, you've never had a steak? Have you had a burger?
Oh, yeah.
Okay, you just haven't had steak. Why is that?
I don't eat meat.
But you eat burger.
Well, I've had one before. I mean, I became vegetarian when I was like 3.
Vegetarian, okay. Do you think you will ever eat a steak?
Criminal.
Okay,
I love
that's
it.
fine.
I don't like meat. I don't want to get food poisoning from it. That scares me. I always vegetarian.
I feel like steak would be one of the less likely things to get food poisoning from.
Yeah.
Yeah, I
As soon
agree
as
with
how you
that.
can eat it.
Rare.
raw.
Yeah.
No, not.
Okay, we'll stop talking about it.
Have you had like rare steak before? Like, it kind of scares me. I can only do medium rare.
Yeah, I
Yeah,
do
it was,
medium rare.
I had a burger one time.
No, I'll get it well done.
Medium rare is
No, it's
Yeah.
When I'm going to a restaurant, I'm ordering my steak medium rare because they overcook it.
Well, the rare steak, I don't like the cold center either. Have you ever had like a
I don't want it to be cold when I'm
yeah,
eating
that's,
it.
That's like how a rare steak
Yeah, that's
is.
not-
Yeah, it's like no coldness there.
That's just because like you can't wait for it to be cooked.
All right, we've wasted 3 minutes on steak, so we got to keep going.
So valid.
But it was valid.
Sorry for the layer period that's gonna happen.
I can't wait for fifth period to hear about our discussion on steaks. All right, pH equals pKa. So if pH equals pKa, that means Ka equals 1 at equilibrium. That means my concentration of HA is going to equal the concentration of A minus. Is this neutral, basic, or acidic? Neutral. It is neutral. Where pH is greater than pKa, my Ka is going to be
Or listen, wait.
less than. How do you know?
Process of elimination.
Okay, but how would you really know?
I don't.
This is logarithmic, right?
Yeah.
So it's kind of opposite. That's how I'm thinking. That's how I'm thinking. My concentration of HA is going to be less than or greater than A minus. You just see. It's less than. It's less than.
Oh, right, because this means that we've gone further past the, it's basic. And if we've gone further past the half equivalence or equilibrium point, then that means that almost all of the acid is gonna be disassociated or reacted with.
Correct.
Into the salt.
Yes.
And the salt doesn't have like a
Yes.
negligible pH if it has.
Yes.
So then it's-
I would
okay.
suggest, I feel like I'm missing a sub-conversation over here, but that's okay. I would suggest maybe taking a picture of those so you have that to study this weekend. Just look over that a couple times. That'd be really good to look at before the weekend.
Next week.
And later.
pH is less than pKa. My Ka is greater than 1, therefore this HA, my undissociated, is going to be greater than my, yes, so this is acidic. This is acidic. You're studying a buffer loose solution. You know the pKa of a solution is 4.2. You measure the pH of the solution to be 8.5. What do you know about the relative concentrations of the acid and conjugate base in solution?
I think HA is less than.
Well, we know that my pH is what compared to my pKa? Greater than my pKa. Therefore,
More of the salt than that.
we know the concentration of the base is going to be what compared to the acid?
Great.
Greater than the concentration of the acid. To the right is a diagram showing the protonated versus deprotonated indicator molecule represented by a large circle. You're using bromothymol blue, which is yellow in pH of below 6 and blue in a pH which you cannot see above 7.5. Above 7.5. Color or label the appropriate circle yellow and blue. So which one would be yellow?
Yellow below 6, the one on the right. Wait. Okay, pH below 6 means that it has to be acidic.
The first one's going to be yellow.
Why?
Well,
Above 7.5.
this should be yellow because in order for it to have a pH below 6, what does that mean? It's acidic.
Yeah.
So has it,
Oh, it hasn't reacted yet.
right, it hasn't donated the proton yet. This one's going to be blue because it has given it away at that point. Does that make sense?
I have no idea what was going on.
It's okay. It's all right. Okay, flip it. If H plus ions are added, the solution becomes more acidic or basic. Acidic. The indicator reaction above will shift to the
Wait, no.
left because the H plus ions by themselves are on the products. And the solution will become more yellow. As more indicator molecules become,
Deprotonated.
no,
Protonated.
protonated. If there are fewer H plus ions, the solution becomes more basic. The indicator reaction above will shift to the right. Correct. And the solution will become more blue. This is because Leichat. This is because Leichat. That was 15 minutes.
We wasted a lot of time talking about Wahlberg. Poor fifth period.
All right, let's just finish this page, and then we will go into our GIM kit. Explain why the pH of a buffered system remains relatively stable.
Add the base reacts with the reacts with the acid, and add an acid reacts with a conjugate.
A buffer can eat. What if I just said that? All right? It's eaten. It can eat / absorb,
The buffer 8.
right?
Yeah.
Yes? Because the conjugate base will absorb the what? Will absorb the acid. And the conjugate acid would absorb the base. A buffer has both, right? It has both a weak acid and a conjugate base, or a weak base and a conjugate acid, and it can absorb either acid or base added to it. Complete the particle diagram showing how buffers work. So here's an aqueous buffer solution. The water molecules are left out because they don't do anything. Study the buffer solution, draw the symbol that represents the A minus and the HA. So what would represent the A minus here?
So just the buffer.
The solid black circle. And what's going to represent the HA? Solid black circle with a little white circle. Change this diagram to what will happen when the acid, H plus ion, is added to the A minus in the HA solution. Complete the equation. So first let's talk about the equation. So what am I adding here? I'm adding in A minus. So this is going to make what? Don't overthink this. HA. So by adding this in, what am I going to make another one of? What's this? Where's this white dot going to go? It's going to go to one of the black dots, right?
And that
So what happened?
we neutralize it.
Yeah, so describing words what happened, you made an HA. You made an HA.
Congratulations.
We made an acid. Change this diagram to what will happen when this base, the OH ion, is added to the A minus and HA solution. So what's going to happen when I add this in?
Is it gonna take a hydrogen and make a water?
Yep, you got it. Nice job. When I add this in, this is going to connect probably to something like this, right? So this is going to go here, and it's going to have 2 connected to it. So OH is going to react with the AH, or the HA, and that's going to make me water plus an A minus. So, Brady, how did you describe that in words?
It takes a hydrogen and becomes a water.
OH took an H plus from HA and made H2O. Made H2O. Okay. We shall stop there. We will finish this 5th period.